All these things are there in your book. So even if you don't want to write, that is fine. Okay. Which one is better? I mean, writing this way or the previous classes, the way we followed? Which one do you think is better from your point of view?
So this one looks much clearer.
This one is clearer.
Yes, sir, it looks fresh.
I think I need to get used to actually writing over here. This is the first time I'm writing it over here. So I think fine. I think I will get used to. Okay. So now we are in mode 2. If you remember, mode 2 is 8-bit, and there is another name which is known as auto reload. Okay, yeah, 8-bit and auto reload. So this is the main difference with mode 1. If you remember, mode 1 was only 16-bit timer. There was nothing as auto reload or something like that. But mode 2, this is 8-bit and this is auto reload. So let us try to see, okay, what is the main difference. So look at the first step, load tmod with the desired value. I think this one is very simple. I mean, same as mode 1, there is no difference. But there is a difference in the second step. If you see your previous class notes, you will see that in this step, we used to load both th and tl with the initial value. But now, in case of mode 2, you will load only th. You will not touch tl. Okay, we will load only th. This is one of the main difference. Then we start the timer. This is also fine. We follow tf. That is also fine. We clear tf. That is also okay. One line is missing. After this clear tf, if you remember your mode 1, there was an instruction that is clear tr. There was an instruction like this, right? Can anyone tell me what is the purpose of this line? Clear trx. What is the purpose of this line?
Stop timer.
Yeah, to stop the timer, right? But in mode 2, we are actually not stopping the timer, which does not mean you cannot stop. Definitely you can stop. But now the name auto reload comes into play. This is the main advantage of this. I mean, the main use of mode 2. We normally use mode 2 where we in general use we don't need to stop the timer. The timer keeps on running. So that's why this instruction is absent in this mode. Of course, you can use it if at any time you want to stop the timer. You can use clear trx and stop the timer. Then we go back to step 4. Now let's see what is actually happening. As we said, we'll load the initial value with th. Assume the value that you are loading in th is fa. Okay, let's keep it simple. Say it is fa. It is thx. So what will happen is tlx will automatically get a copy of the same value that you have given in th. That means TL will also get a value FAH. Then when you start the timer, your TLX will start counting. That means from FAH, it will go to FBH, then it will go to the next one and so on until and unless, how much will it go? Can anyone tell me how much will it go? Before it rolls over to 0, how much will it go? How much?
Sorry, FF.
Yeah, that is what I was expecting. Okay. So before it rolls over, it will go up to FF. Why? Because this is an 8-bit register. Okay, this is the main difference. That 8-bit. This is an 8-bit timer. We are using only TL. Remember, we are not touching the TH. We are only using TL. So it will go up to FF. After FF, you all know it will go to 00. So for all this time, the value of TFX will be 0. And in this step, your TFX will become 1. We know this thing, right? Do we know this thing?
Yes, sir.
Okay. So once it becomes 0, that means your TF becomes 1. Then you go out of the loop, and the moment it has got 0, 0, I mean your TL gets 0, 0 and TF is equal to 1. your TL once again gets this value from TH. So you see, you are not touching in TH. TH always stores the initial value. It is not affected. Whenever you start the timer, the value from TL starts counting. Whenever the timer operation is finished, your TF becomes 1. In that case, TL again gets a copy of what is there in TH. So you clear the TF, you get back to step 4, you start the timer. So when you start the timer, it again starts rolling. I hope you have, of course, I will give you an example after this, but whatever I've said so far, the significance of 8-bit register and auto reload, I hope you have understood. Yes or no?
Yes, sir.
Okay, I can see only one of you is responding. I don't know about others. Well, let's keep on going. So the next page, okay? So now let us see an example. Let me give the question over here so it will be easier for you to understand. In this code, the given crystal is 11.0592 megahertz. We have got two problems over here. Number one says find the frequency of the given code. So the code will be given. Okay. So we will find the frequency. And the second question is find the smallest frequency achievable. Find the smallest frequency that we can achieve. All right. So let's see. And in this example also, we will assume that the machine cycle for jump not beat is 1. Although this is actually not correct, but let us assume it for the time being, for this example or for this chapter. Now let us see the solution. Let me write the code first. Let us assume this is my T mod register. Okay, this is the code. So let us assume this is my T mod register. So if this is a T mod register, after the first line that is move T mod 28, what will be the value in T mod? Can anyone say? Of course you can say, so please do say. What will be the value in T mod?
00100000.
Okay, fine. Very simple. So what are the information that we get from here? Okay, now let us see that. We know that the higher nibble controls timer 1 and the lower nibble controls timer 0. So in the higher nibble, from this one, what are the informations that we get? First of all, what is the mode in both of these cases? For the higher nibble, if we select timer 1, what is the mode?
Mode 2.
Mode 2. And what is the mode in lower nibble?
Mode 0.
0. Good. What is the gate in both the cases?
0.
0. And this is also 0. That means we will go for the software approach. And what is C by T in both of these cases?
0.
Also 0. Fine. So these are the informations that we get after the first line. In the next line, we see that we are using timer 1 because we have got TH1. So we can forget about timer 0. We don't need to worry about this. We can simply focus on timer 1. So we are moving the value TH1. We are moving the value 5 to TH1. Then we start the timer, that is TR1. Jump not bit TF1 back. Fine, we stay in this loop. Then we complement P1.0. That means the output of P1.0 will be something like this. It will be high for some time. It will remain low for the equal amount of time. Again, it will be high. It will remain low. And this process will go on. So this is the output that we are getting from P1.0 from this code. Then we clear the, sorry, it will be TF1. Yeah. So we clear the timer overflow flag. Then we go back. So this is the output. So let us come to the solution that we need to find. The first thing is we need to find the frequency which is being generated in this port, that is P1.0. So we can neglect the overhead. Neglecting the overhead, how do we find the frequency? How do we find the frequency over here? What is the first thing that you need to do? You don't have to say the answer, just tell me the steps. I will do
Sir,
the
what does it mean by
calculation.
neglecting the overhead?
Neglecting the overhead means you will consider the machine cycle only for this line. You will not consider the machine cycle for any other line. Okay. Now tell me, what is the first thing that we need to do?
We need to find the time for one machine cycle.
Okay, right, exactly. So we know that if the connected frequency is 11.0592 megahertz, what is the machine cycle?
1.085 microsecond.
1.085 microsecond. Remember, during your exam, don't write it like this directly. Okay, you need to show the calculation. I'm writing it directly because I know that all of us already know the calculation. But during the exam, please show the calculation. Fine. So we have got the duration of one machine cycle. What is the next step that we have to do?
Find the delay count.
Okay. So before finding the delay, we need to find the total machine cycle, isn't it?
Yes, sir.
Okay. So how much is your total machine cycle in this case?
Total machine cycle in the loop.
Total
250.
machine, how much?
250 maybe.
51, I think.
Okay. How do we calculate? Tell me, how do we calculate?
FF minus 5 plus 1.
FF minus 5 plus 1. Okay. How much is it? Tell me.
It's 251.
Tell me in hex. Since you have calculated in hex, so tell me in hex.
FD.
FDH. So definitely now if you convert this into decimal, now how much do you get?
$251.
Right.
FD na.
FD হচ্ছে নাকি এটা কত?
Sir, it should be FB. AB. B.
It should be FB.
FB, sir.
Yeah. All right. So this is one of the step which is correct. Okay. The way you have calculated, but there is a simpler calculation. You could simply write 256 minus 1. Sorry, not minus 1. Just a second. You can simply write 256 minus 5 and it will give you 251 directly in decimal. It is same as 16-bit. If it were 16-bit, we would have subtracted from 65536, right? You know that. So since it is 8-bit now, so we subtract from 256. So we have got 256 machine cycle. The next thing is we need to calculate the delay. How much is the delay? How can we calculate?
51 multiplied by 1.085 microseconds.
Right. So 251 multiplied by 1.085 microsecond. How much do we get? It should be-
272.335 microsecond.
Okay, microsecond. Therefore, what is the time period?
2 multiplied by this.
2 multiplied by delay, and your time period will be 544 point, I think, yeah, 67 microsecond. So now we can calculate the frequency, which is 1 over time period, and your answer should be 1.83 kilohertz. So is the first portion understood to all of you? How we calculated this? Have you understood? Yes, no, something?
Yes,
Yes,
sir.
sir.
Now let us move on to the next portion, which says find the smallest frequency that we can achieve. So we see that frequency and time period are inversely proportional to each other. So to get the smallest frequency, we need the largest time period. So to have the largest time period, what should be the value that should be loaded in TH1? To get the largest time period, what should be the value which is to be loaded in TH1?
0, 0.
Exactly, it should be 0, 0. So in that case, let us directly find the time period. So in that case, what is the time period? 2 into 256 into 1.085. Can I write this thing?
Yes, sir.
Okay, so we understood, right? So the time period will be 2 into 256 into 1.085 microsecond, which will come about 555.52 microsecond. So fine. Now, once we have the time period, we can find the frequency by 1 over time period, and it will be 1.80 kilohertz. So is this example understood to all of you? Both the portion A and B. Did you understand?
Yes, sir.
If you've understood, now tell me one answer. Say, in the question, in the exam, you get a question that generate a frequency of 1 kilohertz using mode 2. This is the question. And now you know that the smallest frequency is 1.8 kilohertz. But your question says generate 1 kilohertz using mode 2. What will you do? কেউ একজন বলার চেষ্টা করতেছে বাট কথাটা ডিস্টর্টেড, আমি শুনতে পারতেছি না কিছু।
Sir, we need
Hmm.
we need to incorporate multiple level of delay, maybe.
Okay, let's be more specific. Where you are going is correct, so be more specific. What will you do? What do you mean by multiple level for delay?
I mean, sir, after clearing TF1, there we can use another line, like we have to calculate how much more machine cycle we need, and we can move that to TH1, and after that we can start again the timer for that much machine cycle, and then we can come back to
Short jump back.
again.
Then what will happen is, if you go that way, yeah, I think that will also work. Yeah, that will also work. That is fine. There is another way, simpler way, to use a loop to control the delay, and we will have a register which will control the loop. So you will call the delay from that loop. Did it sound very complex, what I just said?
Yes, sir. Can you explain again?
Okay, what I'm saying is we can use another loop within which we will put this entire delay, this portion. So what will happen, we will call the delay a number of times. I mean, over here we do not have a delay subroutine, but we can have a delay subroutine, isn't it? Inside the delay we can incorporate this timer, right? We can simply write delay over here and start the timer, isn't it? Are you getting me?
Yes, sir.
And we'll
Yes,
place this line after the delay. So what we will do, instead of calling the delay one time, we will call the delay multiple times, say 2 or 3 times based on our requirement. So what will happen is your this period, your this delay will increase, right? Because you are
Yes, sir.
calling the delay 2 or 3 times instead of calling it just once, you are calling it 2 or 3 times. So if you call 2 or 3 times, what will happen? Your delay will increase. So if your delay increases, your time period will also increase, isn't it?
Yes, sir.
So finally your frequency will be smaller. So what is the another instruction that we need? We can use this instruction DJNZ, then you can have a register and then you can give the label name. That's it. So we use another register to control the loop from where we are calling the delay. You can go through example 915. This is the exact same question, how to create 1 kilohertz. Okay, you can go through that. That is whatever I just said, only this line will be needed, DJNZ, and you will control from where you are actually calling the timer. That is the only difference you have to make. That's it. Is it understood?
Yes, sir.
All right, I can still hear only one voice. I don't know what is with the rest of the people. Let's move on. I think I can ask someone. Let me see how much concentration you are having. Let's ask. ID 98. Are you there? $98 absent naki? Okay. 98 is absent. Let us call someone else. Okay, ID 16. ID 16, are you there? Am I audible? Can you hear me? Others?
Yes, sir.
Okay, so let me
Yes,
just
sir.
write down. Okay, let me write down the IDs those who are absent. Okay, I thought I was. So ID 16 and 98 are absent, right?
Sir, 98 is present. Sir, I'm present.
কই তোমাকে কতক্ষণ ধরে ডাকতেছিলাম তো?
Sir, আমার নেটওয়ার্ক মানে নেট ফ্লাকচুয়েট করতেছে।
Okay, so ID 16 is only absent. Okay. All right. So the question is for 98. Say you are given a task that generate a time delay of 150 machine cycle, right? So what should be loaded in TH? That is the question. What value should be loaded in TH to generate a machine cycle of 150? Can you find it? How we can, calculate the value? Do you know the steps? $98, yes or no?
Sir, I couldn't hear you, sir. My net is very bad today. So অনেক ফ্লাকচুয়েট করতেছে।
তুমি ক্লাস করতেছো কেমনে?
মোবাইল থেকে।
Okay, fine. Let me ask someone else. Okay, what about 73? 73, are you there?
Yes, sir.
Acha. Parva, can you say how we can calculate the value of TH, which is to be loaded for 150 machine cycle?
Yes, sir. Sir,
Okay.
we have to divide the frequency of the oscillator by 12. And then
That
we
was
have
okay. Wait. We have already performed those things. Like what you are saying is, say I have told you that create a frequency of 10 kilohertz then we need to find the time period first, right? By 1/10 kilohertz, we can find the time period. Then after finding the time period, we can find the machine cycle from the time period divided by the crystal. All these things is already passed. We already found the machine cycle. So we have already found the machine cycle. Now what is the next calculation?
Sir, the sinusoidal loop, we have to calculate the total machine cycle.
Total machine cycle to pay. We have already got the total machine cycle 150. What is the next step? We know that we have to generate 150 machine cycle. Next step is what? Okay. কাকে জিজ্ঞেস করছিলাম? 73. Okay, let's go serially. 74 কি section এ?
Yes, sir.
Okay, so can you answer?
No, sir.
75 কি section এ? I don't see a 75.
So 75 is not in IoT.
Oh, 75 IoT তে নাই। আচ্ছা ঠিক আছে, let me just open it. I'm just simply wasting time. I know that most of you are not paying any attention. Anyway, so how should we do it? Anyone? How can we do it?
256 minus 150.
Right, 256 minus 150. How much do we get? 106, isn't it? In decimal. So if you convert this into hex, how much do we get?
So 6A.
6AH, right? So what will be our instruction? Our instruction will be move TH, comma 6AH, isn't it? If you want to generate 150 machine cycle, then this is the instruction that we have to use. But if I say this one is correct, no problem with that. Okay. If I say that we can also write move TH, comma hashtag minus 150. Will this give me the same machine cycle of 150 or not? What do you think? Yes or no? Yes.
So
or
what is
no?
the hex of minus 150?
Find out. You have your calculator in front of you, so you can find out.
Yes, sir. It will work, I guess.
Okay. So how much did you get? The hex of 150 is how much?
So FF6A.
So we have got a lot of F, then we have got 6A. We know that TH is a 8-bit register and all this F represents simply a negative sign. So the only number that will be loaded in TH is 6A. So we will get the exact same output. So what I wanted to say is, if you are in mode 2, this is only applicable for mode 2, okay? If you are in mode 2 and if you found out how many machine cycle you need, then instead of doing this calculation, you can simply enter the negative of that machine cycle into THX and you will get the expected result. Is it okay? Have you understood?
Sir, can you repeat again?
Okay, what I'm saying is, if you are in mode 2 and after all these calculations, you have found out how many machine cycle you need, then after finding the machine cycle, you don't have to do this calculation. Okay, this is not necessary. Instead of doing this calculation, you can simply write the negative of the calculated machine cycle into TH. I mean, you can move the negative of the machine cycle into TH, and by that you will get your expected result. That is what I have just proved. Normally, after the machine cycle, we perform this calculation. Then we find the number in decimal. Then after that, we convert into hex, and that is the number we load in TH. But instead of doing all these calculations, you can simply insert the negative of the machine cycle into TH, and you will get your exact same output. Okay? Have you understood now?
Yes, sir.
Okay, up to this, is there any question, any one of you? All right, if there is no question, we are almost. So I have taught you a lot of things in chapter 9. So definitely you need to teach yourself something as well. So this is for your self-study. Section 9.2, okay, read it on your own. This is a very small section. You can, I mean, you will understand definitely if you understand the classes that we have done so far. After that, if you study section 9.2, you will understand, and you can exclude section 9.3. Section 9.3 deals with C programming, which you are not interested in, so we can exclude section 9.3. So with this, we finish chapter 9. Can I move on?
Yes, sir.
Yes,
So
sir.
if we can program the microcontroller with C programming, why are we using assembly?
Why are we assembling? This was, your assembly has got certain advantages, right? We have discussed it in our previous course, I think. You can directly deal with the internal structure of your microcontroller. If you program in assembly, sorry, if you program in C, then your assembler, not assembler, sorry, your compiler will perform all those things. But when you code in assembly language, you can directly deal with the hardwares of the microcontroller. Is it okay?
Yes, sir.
I mean, you get to see the microcontroller from much closer distance. Okay, that is why. Please write whatever I'm writing. Please write. All these are your self study from chapter 10. Don't get afraid just by seeing a lot of topics and self study. Okay, you don't have to do any mathematical or code related things from chapter 10. You don't have to go through all those things. All you need to do is whatever topic I have written, all this has got 2 or 3 lines definition and explanation, something like that. Okay, some might have 1 or 2 figures over there. These are very simple and all theoretical. So just go through those things. I mean, go through these topics. You don't need to go for any example or code or anything like that. Actually, teaching something which is completely theoretical is quite boring. Okay, it is better when we teach something which relates your numerical calculation or coding related things, then we have something to explain. But if I simply read the definition and tell you the meaning of the definition, that actually doesn't make sense. Okay, so please go through all these topics at least once by your own. And even after that, if you fail to understand, definitely I will explain all those things. All right, and this is all we need to know from chapter 10. So to summarize, after your midterm, today is the last class before your Eid. I think all of you already know that. So after midterm, before your Eid, we have completed chapter 6, chapter 9, and chapter 10. In our syllabus, we still need to complete chapter 11 and chapter 13 completely. And after that, there are some portions from chapter, I think 14, 15, and 17. I mean, these are not complete chapters. We don't have to go through the complete chapter. Some portions of these 3 chapters should be covered. So after the Eid, I think we'll still have more than 1 month, which should be more than enough to cover the syllabus. So I think we are, I mean, I just wanted to give you a scenario where we are and how much we need to go. So I think we are okay by this time. We just need to finish these few things after Eid. All right. So if you have anything to say up to this, anything at all, if you want to say.
Sir,
Hmm.
I have a question, sir. Sir, in our project given at lab,
Mhm.
I have faced a problem about this machine cycle that যত স্যার বাংলায় বলি যতগুলা মেশিন সাইকেল জেনারেট করতে হয় আমার টাইমটা ঠিক 1 সেকেন্ড হওয়ার জন্য ততগুলা মেশিন সাইকেল আমি মানে পাই না কোডে, মানে আমার আসে না। তো আমি তখন অ্যাকচুয়ালি মেশিন সাইকেল শর্ট হয়ে যায়। দেখা যায় যে অ্যাকচুয়াল স্টপ ওয়াচে যে ইয়েটা হচ্ছে, মানে যে টাইমটা আসে আমার কোডের স্টপ ওয়াচে এর থেকে মানে টাইমটা সেম আসে না। তো স্যার এখানে আমি কি এটা কি পারবো যে একটা জাস্ট এমন একটা লুপ অথবা এমন কিছু ইউজ করে যে যেটা দিয়ে আমি এক্সট্রা মেশিন সাইকেল দিতে পারবো, মানে এইটা
এটাই তো, I mean, whatever you just said, that is what we discussed over here, right?
Yes, sir.
Just use another register to control the delay from where you are calling the delay. Then you call the delay for the required number of times. In that way, you can increase your delay, isn't it?
Yes, sir.
So you can try doing that.
এইটা তো স্যার মানে এইটা তো আজকে জানলাম স্যার, কিন্তু লাস্ট ইয়েতে মানে আমাদের প্রজেক্ট হয়ে গেছে, মানে সাবমিট করে দিলাম।
এটা তুমি কেন এখন জানলা? Now I see. This is the thing that you have covered in chapter 3. You go back to chapter 3.
Yes.
You will see that the concept of inner loops we have covered in chapter 3. So this is a concept of chapter 3 that we are implementing on timer. That is the only difference. But in chapter 3 also you already knew how to create delays, isn't it? How to create more delays. You already know all these things. So this is not okay.
Okay, thank you, sir. আমি প্রজেক্ট করতে গিয়ে একটু সমস্যা করছিলাম।
তোমাদের প্রজেক্টের ডেট শেষ নাকি?
স্যার ওই যে জমা দিয়ে দিছি, মানে এখনো কিছু মেশিন সাইকেল আপ ডাউন আছে, এই কারণে অ্যাকচুয়ালি সুন্দর মতো আসে না।
Machine cycle, it will differ to some extent. Frankly speaking, you will never get the exact machine cycle, but that also you are not supposed to be able to calculate with time watch or something like that. It is not possible. The only way you can find out the exact machine cycle is if you are using an oscilloscope, which none of us are doing. So the difference that is being created is not visible.
Okay, sir. Thank you.
All right. Okay. Anything else? Any one of you?
স্যার 7 মিনিট পর যদি 1 সেকেন্ড ডিলে দেয় এটা কি প্রবলেম করবে?
7 সেকেন্ড পরে 1 মিনিট ডিলে?
7 মিনিট স্যার, 7 মিনিট পর 1 সেকেন্ড যদি ডিলে দেয় প্রজেক্ট।
No, it depends on what was your task.
জি স্যার, মানে ক্লক স্যার, মানে ইন দ্য ল্যাব।
হ্যাঁ, ল্যাবে কি ক্লক করতে হবে?
জি স্যার, প্রজেক্টে স্যার যে ক্লককে 7 মিনিট পর 1 সেকেন্ড যদি ডিলে দেয়, মানে ডিলে ক্যালকুলেশন করার পর
প্রতি 7 মিনিট পর পর 1 সেকেন্ড করে ডিলে হবে?
জি স্যার, মানে ডিলে দিতেছে আর কি, এটা কি প্রবলেম করবে?
এই ডিলেটা কি সরাইতে পারতেছ না?
সরাইলে স্যার বেশি সরে যায়, আবার কমাইলে বেশি কমে যায় স্যার, এরকম।
ভ্যালু আনা
1 সেকেন্ড ডিলেটা তো একটু বেশি, 1 সেকেন্ড তো অনেকখানি ডিলে।
স্যার 1 সেকেন্ড ডিলে ক্যালকুলেশন করার পরেও অনেক মেশিন সাইকেল হিসাবের বাইরে থেকে যায়। আমরা যেগুলা লুপের ভিতরে লুপ অনেক কিছু ইউজ হইতেছে ওইগুলানের সাইকেল ক্যালকুলেট করে এক্স্যাক্টলি।
এইটাই তো আমি বললাম যে আমরা তো সবসময় আমরা ওভারহেড সবসময় এক্সক্লুড করি না, এই ওভারহেড এক্সক্লুড করার কারণে এই জিনিসটা হয়। বাট ডিফারেন্স তো এত হওয়ার কথা না, 1 সেকেন্ড হওয়ার কথা না, তো ডিফারেন্স তো অনেক কম হওয়ার কথা।
আই মিন স্যার 7
Sir,
মিনিট
এই যে-
পরে যে 1 সেকেন্ড হচ্ছে এটা তো খুব বেশি ডিফারেন্স না।
7 মিনিট পরে 1 সেকেন্ড, ঘন্টায় তাহলে কত সেকেন্ড পিছাচ্ছ? 7 8 সেকেন্ড, অলমোস্ট 8-9 সেকেন্ড, তাই না?
জি
More
স্যার।
than 8 seconds. More than 8 seconds in 1 hour, I think that's fine. That should not be a big deal. I don't think that will be a big deal. Anything else?
স্যার আমরা হচ্ছে মাইক্রো প্রসেসরের ল্যাবে যে ক্যাপাসিটর আর রেজিস্টার এক্সট্রা কানেক্ট করি, এই দুইটার কারণ কি?
ক্যাপাসিটর আর রেজিস্টার, এগুলি জানতে হলে তোমার ইন্টারনাল স্ট্রাকচারে ঢুকতে হবে। The internal structure of microcontroller, that is to safeguard various components, I think. So we need to go for internal structure, which is in there in chapter, কোন চ্যাপ্টারে ছিল? 7-8 I think. Most probably chapter 8 deals with internal structure, which it did not cover.
ওকে স্যার।
I can see a lot of you guys are absent today. So should I take the attendance? তোমাদের একমাত্র তোমাদের সেকশনে মনে হয় অ্যাবসেন্টটা সবচেয়ে বেশি compared to the other sections. Your section has the largest number of absentees. But I think I'll take the attendance. Okay, let me take the attendance. Once you hear your ID, just raise your hand and keep your hand risen. Okay, don't lower your hand. Okay, 16 series 35 147 of 16 series. Niloy. Okay, definitely you are not here. Then 9 13